हेलो फ्रेंड्स, आप सभी का निरंकारी वीडियो चैनल में स्वागत है। इस चैप्टर में हम मोशन इन ए स्ट्रेट लाइन, एक सीधी रेखा में गति चैप्टर के अंतर्गत एक्सेलरेशन, त्वरण टॉपिक पे चर्चा करेंगे। एक्सेलरेशन The rate of change of velocity of an object with time is called acceleration. समय के सापेक्ष वेग परिवर्तन की दर एक्सेलरेशन कहलाती है। The rate of change of velocity with respect to time is called acceleration. It tells how fast the velocity of object. It tells how fast the velocity of an object changes with respect to time. In formulation form, the acceleration equal change in velocity upon time taken, delta v upon delta t. Acceleration is a vector quantity. Acceleration is a vector quantity. Acceleration एक सदिश राशि होती है। It has the same direction as that of change in velocity. It has the same direction as the change of velocity. The SI unit of acceleration is meter per second square, and unit of acceleration in CGS system is centimeter per second square. The dimensional formula of acceleration is m0 L t minus 2. Now we will describe different types of acceleration. Different types of acceleration. Uniform acceleration. Number first, uniform acceleration. The acceleration of an object is said to be uniform acceleration, the acceleration of an object is said to be in uniform acceleration if its velocity changes by if its velocity changes by equal amount in equal interval of time. Number second, variable acceleration. Variable acceleration. The acceleration of an object is said to be the acceleration of an object is said to be variable acceleration if its velocity changes by if its velocity changes by unequal amount of velocity in equal interval of time. यदि समान समय में वेग परिवर्तन की दर अलग अलग आ रही है तो वो वेरिएबल एक्सेलरेशन कहलाएगी. नंबर थर्ड इज एवरेज एक्सेलरेशन. एवरेज acceleration for an object moving with variable velocity. For an object moving with variable velocity, the average acceleration is defined as the average acceleration is defined as the ratio of total change in velocity. Ratio of total change in velocity of the object to be total time interval taken of the object to the total time taken. We average average equal total v2 minus v1 upon t2 minus t1, that is delta v upon delta t. Next, instantaneous acceleration. Instantaneous acceleration The acceleration of an object, the acceleration of an object at a given instant of time, at a given instant of time, or at a given point of its motion, or at a given points of its motion, is called its instantaneous, acceleration. In mathematical form, A equal delta V upon delta T. A equal limit delta T tends to 0, then delta V upon delta T becomes d dt of V. Thus, acceleration is the first order derivative of, thus instantaneous acceleration is the first order derivative of, derivative of velocity, and second order derivative of rate of change of displacement with respect to time, Now A equal, in mathematical form, A equal d dt of V, or A equal d2s upon dt2. Second order derivative, and this is a first order derivative. Now we will define positive acceleration and negative acceleration. Positive acceleration. If the velocity of an object increases with time, if the velocity of an object increases with time, the acceleration is positive. The acceleration is positive. When a bus leaves a bus stop, for example, when a bus leaves the bus stop, its velocity increases with respect to time, then acceleration will be positive. Second heading is negative acceleration. Negative acceleration. If the velocity of an object, if the velocity of an object decreases with time, then the acceleration is negative type. When a bus slows down and approaching a bus stop, for example, when a bus slows down and approaching a bus stop, then acceleration is negative type. The numerical problem is the position of an object moving along x-axis is given by the position of an object. Example, the position of an object moving along x-axis. Moving along x-axis is given by x equal to a plus bt square. X equal to a plus bt square, where a equal 8.5 meter, 8.5 meter, and b equal 2.5 meter per second square. 2.5 meter per second square, and t is measured in second, and t is measured in second. What is its velocity at t equal to 0? What is its velocity at t equal to 0 and t equal to 2 seconds? What is the average velocity between? What is the average velocity between t equal 2 seconds and t equal 4 seconds? The solution becomes, we know that position of an object is given by x equal a plus bt square, and instantaneous velocity d dt of x, v equal d dt of x, then d dt of a plus bt square. Then it becomes, because a is constant, and it becomes a v equal d dt of a plus bt square. Then it becomes 0 plus b into 2t यानी 2bt. Then we find velocity at t equal 0 second equal to by putting t equal 0. It becomes 2 into b into 0 equal to 0. Answer becomes 0 meter per second and t equal 2 second. At t equal 2 second, then the velocity equal 2 into b into कितना 2, यह हो जाएगा 4b and putting b equal 2.5 meter per second square, then velocity at 2 second becomes 4 into 2.5 meter per second and it becomes 10 meter per second. Now we will study about kinetic equation for uniformly accelerated motion. Kinetic equations for uniformly accelerated मोशन. एक समान गति के लिए, एक समान त्वरण के लिए गति के समीकरण. Consider an object moving with constant acceleration. Consider an object moving with a uniform acceleration along positive direction of x-axis. Along positive direction of x-axis. Velocity after a certain time. We will find out velocity after a certain time. Acceleration equal change in velocity upon time taken. A equal v minus v0 upon t minus 0. Then AT equal V minus V0, then V equal V0 plus AT, where V0 is the initial velocity of a moving object, A is the acceleration, and T is the time taken, and V is the final velocity. Second heading is distance covered in a certain interval. Distance covered in a certain interval. Average velocity of the object, average velocity of the object in time interval T is given by the formulae V average equal initial velocity plus final velocity, initial velocity plus final velocity upon 2, that is V0 plus V upon T. So x minus x0 equal V0 plus V, V0 plus V upon V0 plus V upon 2 into becomes T, and it becomes x minus x0 V0 plus AT upon 2 into T, then it becomes x minus x0 2 V0 plus 2 V0 plus AT upon 2 into T, x minus x0 2 V0 T plus AT square upon 2. Here becomes x equal V0 T plus half AT square, and this is the second motion equation. Next problem is a velocity at a certain position. velocity at a certain position. Velocity at a certain position. V equal V0 plus AT. We know that. V equal V0 plus AT. Then V minus V0. Then V minus V0 equal AT. Displacement equal V plus V0 upon 2. V plus V0 upon 2 into T, and it becomes x minus x0. Then it becomes V0 plus AT plus V0 upon 2 into T equal x minus x0. It becomes 2V0 plus AT upon 2 into T equal x minus x0. And it becomes V0 plus half V0T plus half AT square equal x minus x0. V plus V0 upon 2 into T x minus x0. Then V plus V0 equal into T equal 2x minus x0. Then V plus V0 equal 2 upon T x minus x0. V minus V0 equation number 4 and V plus V0 equation number 5 by multiplying equation 4 and equation 5. V minus V0 into V plus V0 AT into 2 upon T x minus x0. It becomes V square minus V0 square, and it becomes T to 2 cancel 2a x minus x0. Then V square equal to V0 square plus 2a x minus x0, and V square becomes V0 square plus 2a. Yes. where S is the total displacement covered. Now we'll define equation of motion by calculus method. Equations of motion by calculus methods. First equation of motion. First equation of motion. Acceleration is defined as A equal d dt of v. Here dv equal a dt, dv equal a dt. By integrating, this is the equation number 1. By integrating this equation on both sides, integral dv equal integral a dt, and it becomes v equal a integral dt, v equal a at, and v equal u plus v equal at and v equal a, t को 0 से t तक कर दीजिए, तो v इक्वल a t माइनस 0. And v becomes u to v, then v minus u equal at and v equal u plus at. This is the first equation of motion. Now we will derivate second equation of motion. Second equation of motion. Second equation of motion. Velocity is defined as v equal velocity is defined as B equal d dt of S, then ds equal v dt, and we integrate integral ds equal integral v dt and ds equal v integral dt, and it becomes s from 0 to s, 0 to s, and 0 to t. It becomes 0 to s and v, it becomes t, 0 to 2, it becomes s minus 0 and v, t minus 0, and it becomes x equal vt, and v equal u plus at into t. ds 0 to s, ds 0 to s, and v ds 0 to s and integral v into dt. It becomes 0 u plus at into dt. It becomes ds 0 to s and integral u dt plus integral at dt, and it becomes s 0 to s and u dt 0 to t plus a, and it becomes t dt 0 to t, s minus 0, and it becomes u t minus 0 plus a t square upon 2 0 to 2. It becomes s equal ut plus a t square upon 2 minus 0 square upon 2, s equal ut plus half at square. This is the second equation of motion by integrating methods. Now we will derive third equation of motion. Third equation of motion by integration by the definition of acceleration and velocity. By the definition of acceleration and velocity, A equal d dt of v, and it becomes dv upon ds into ds upon dt, and it becomes dv upon ds into v. A equal dv into v upon ds. It becomes a ds equal v dv. A integral ds and v integral v dv. Displacement changes from a integral ds 0 to s, and it becomes integral u plus at integral v dv. A s 0 to s, and it becomes v square upon 2 0 to v. It becomes as minus 0 and v square upon 2 minus 0 square upon 2. As equal v square upon 2. As equal v square वेलोसिटी ये हो गया v टू u, ये हो गया u स्क्वायर अपॉन 2 as माइनस u स्क्वायर अपॉन 2 2as इक्वल v स्क्वायर माइनस u स्क्वायर, देन v स्क्वायर इक्वल u स्क्वायर प्लस 2as. This is the third motion of equation. Now motion under gravity. तो फ्रेंड्स, अपने अगले लेक्चर में ग्रेविटी के अंतर्गत, गुरुत्व बल के अंतर्गत हम मोशन के इक्वेशन की चर्चा करेंगे। इसलिए आप हमारे अगले वीडियो लिंक की प्रतीक्षा करें। धन्यवाद।